Hello all and welcome back. So in this video, I would like to talk about how can we do a traversal on a disconnected graph. So in the types of graph video, we talked that what is a connected graph in which each and every node, it is connected to the other node, right? So we were taking a graph like this. Let me draw it back. We used to have a zero node. Let us copy multiple nodes here. In our graph, it was a connected one, right? So from one node, there was always a way that I could have gone to another node. So let us have this graph, everyone. This time what I'm doing is, so I'm not connecting this 0 and 5, right? So that is just one thing which I'm not changing. 0, 1, 2, 3, 4. This was 5. This overall connection is not drawn here. Now, let me just remove that in our code as well to see if there will be some change or not. Now, this is a graph traversal DFS code which we wrote. Here, what I'm doing is I'm just removing this, commenting this particular edge. Okay. Now let me print this out and see if we will be able to see our full graph or not. And you will see one thing on the right, if you will see, we are just getting 0, 1, 2, 3, 4. So yes, the DFS traversal happened, but still I'm not able to see the fifth node. Let us understand why is that. Now, since this is a disconnected graph, let's say you start from 0. We will go on 1, we will go on 2, then 3, then 4. Then we will return. There is no way I could have gone to 5 because it is not connected. If let's say it would have been a graph where disconnected components were there, let's say if this would have been 5 or 5 and 6, then also same issue would have happened because there is no way from 0 you can go to 5 or 6. As a as a result of this particular thing, what happens is that we are not able to print out our whole graph with the code which we have written. Okay, so let us try to understand if we can do anything to correct this, everyone. I will be doing the same for DFS. Then I'm pretty sure that you can do it for BFS. Okay, great. So let us see what we are doing and what can be changed. When I'm calling my DFS function, I'm giving it a start vertex, which is always 0. Now the idea is that if I would have given 5 as a start vertex, then it would have just gone to 5 and 6. And again, there would have been no way that I can reach out to this part of my graph, right? This component. So you can take this as a component 1, 0, 1, 2, 3, 4, 1, and 5, 6 as the component 2. If two components are not connected to each other, then the one which you start with, you can just print out that one only, right? There is no way that you can print out the other one. So based on that, what I think we should do is, all is good here. So DFS, all that is fine. When we are calling this DFS recursive, okay, I should write a loop here, I think. So for node, or let's say vertex, in range of self dot vertices. This time, instead of passing the start vertex, what I will be doing, everyone, I will be going to each and every vertex and I will be calling with respect to that, provided it is not visited. So when I will call on 0, it will go and visit this component, and 0, 1, 2, 3, and 4 will be marked as visited. Next, I will check for 1, but it is visited, so no need to just call that. Same for 2, same for 3, same for 4. But when I will come to 5, it will not be visited. And hence, what I can do, I can thus call on this DFS again, and DFS is going to just go and print it out. Okay. So let us do one more thing. Let us just add this 6 vertex and let us add a edge. So graph dot add edge 5 to 6. Great. So what we have to do now, everyone, we can just get rid of the start vertex. This is something which we don't require now. Instead of start vertex, I will be passing this vertex. And the condition is if visited of vertex equals false. In case this vertex is not visible, then we can call the same, right? So first we will see 0, 1, 2, 3 because it will call on 0 only. Then we will see for 5 and 6. That is what we should see now. Okay, and maybe what we can do as well is we can do print calling for a component so that we should know that there are two components. Okay, great. I think the way we have written the code, the way we have divided this particular class is pretty well written, so no other change should be required. We are sending this visited, so it will be with us only. We have defined it here and we can use the same. So let us run this now, everyone. Okay, where's the error? I think, yeah, so we have to num visited. Yeah, we have to send out this list can object cannot be interpreted as an integer. So this should be range in which line number 31 for vertex in range dot num vertices. Okay, so I sent out this vertices. It is a list, not an integer. And now we can run the same. See, first it is saying index out of bounds. I think that we checked with some overall node. Next, it is calling for a component 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay. After that, I think we made a mistake. So we have to make 7 nodes if we are adding the 6. So we are seeing out of bound for this particular because we just asked for 6 nodes and 0 to 5 or 6 nodes. That's the reason we are not even able to see this edge as well, right, everyone? So now let us run this and we should see 5 and 6 here. And see, 5 and 6 are here. It is also telling you how many components are there. So that's a question which can be done with this particular approach as well, that how many components are there, disconnected components are there in your graph. Okay. We also get a question. So you will be doing that going forward where what you have to do is you have to return different components. So this 0, 1, 2, 3, 4 is one component. Then this 5 and 6 is another component. There can be 7 and 8 here as well. We have to return the different components. Okay. And I believe that it is a lot easy now. We were maintaining this DFS result.append, right? We were maintaining this DFS result. In this, instead of a vertex, you can just maintain the whole list. So maybe we can return this DFS result and keep on adding that into some answer list here. So we'll make sure that you attempt that question. Okay. So it will be one of the exercise and code exercise in this course only. But I hope you get the idea. Now let us go and see for BFS again. Here also idea is same only. We just have to make sure that when we are now maintaining a queue, okay, we can just have a separate function here and we will call this BFS from that function with a vertex. Okay, so this is something now which you have to do. What I am doing is I am making sure that your input looks like this. So input graph is now like this. We are calling BFS here. And now if I run this, you will not see 5 and 6. See 0, 1, 2, 3, 4. Again, what have happened? 0, then 1, 2, 3, 4. Okay, so we have to make sure that you are able to now code it out for BFS for disconnected graph. Pretty sure you will be able to do it because we have written a very nice code and I don't see any problem in that. Like the way we have discussed it, all of you should be able to write the code for this. Just create a separate DFS function, BFS function. Okay, call this BFS traversal and just call this BFS traversal with different start vertices and everything will be done. Okay, so great all. I hope each and everything is clear in this particular case. Now our DFS and BFS functions are complete because now given any graph, it will be able to print them out. Earlier, we missed out on this particular small caveat where if the graph is not connected, we will not see the full graph in our traversal. We will miss out on some parts of the graph. Okay. Great all. So let's meet in the next video. Till then, please make sure that we will have some questions now based on DFS and BFS. You are able to do that because in graph, again, in majority of the questions, you will just be doing or applying BFS and DFS algorithm. Okay. Thank you.